I'm Ralph Bagnall, your host for Wood Academy, and in this episode, we're building a drill press table. And it incorporates some pretty cool features that you're going to want to have on your drill press. Now, as always in the shop, eye protection and hearing protection is an absolute requirement. But we're going to be doing a lot of work with the drill press in this episode, and it has its own issues that you need to be concerned about. Long sleeves should be rolled back and kept tight against the wrist to prevent them from getting caught in the spindle, which could pull you into it. Long hair should also be secured to stay away from that. The bits themselves are sharp and again are spinning. You can be using a sanding head on here. That needs to be paid attention to. The part can grab and be thrown. And of course, if you use a circle cutter, you've got a really large wing that's spinning and will wrap your knuckles quite severely. So when using the drill press, just like any other tool, it requires care and attention to keep yourself safe. Remember, your best safety device is up here. You are your own best protection in the shop. During my career as a woodworker, I've built a number of drill press tables. So I've learned what I like and don't like for features to be included. And there are some new products available that allow me to do the design exactly the way I've always wanted to do it.
To begin with, the fence position is adjusted by clamping to the edges of the table. Dovetail grooves are provided on the table and the fence to allow for the use of clamps or stops as needed. The throat plate has been positioned to improve the use of material, but perhaps the best new feature is a vertical face positioned on the back that simplifies drilling into the ends of tall parts.
Those are the features we're incorporating in this table. Let's get on with the build.
The plans for this episode come with drawings for 2 different sizes of drill press, but you may need to alter them to fit your table. The vertical face needs to fall directly under the quill when the table is rotated. A piece of scrap cardboard clamped to the table and a marker secured in the chuck will let you confirm the size and layout of your table. A 2 by 4 foot section of good cabinet grade plywood is all that's needed for all the parts of any size table. The table itself is cut first, then the vertical face, and the fence parts can be cut later from the leftovers. It's best to lay out all the details before any milling is begun. The rear edge is stepped so that one side clears the elevating handle and the other side extends backwards for the vertical face. When building jigs, I like to radius both inside and outside corners, and a quarter is excellent for laying these out. Getting everything drawn in before the work starts is especially important in a project like this that's not symmetrical side to side. Once the parts, including the fence pieces, are cut to size and laid out according to the drawings, milling the details can begin with the forming of the dovetail slots. I recommend cutting a relief slot any time an undercutting bit, like the dovetail, is going to be used. It needs to be slightly smaller than the profile being cut and can be done either at the table saw or on the router table. The relief groove removes excess waste, which greatly improves the cut quality and extends the life of the bit. Go ahead and mill the dovetails in the fence, table, and vertical face all at the same time. And here's a pro tip for you. If your router table fence cannot be moved back far enough to cut one of these grooves, a straight edge clamped front to back on your table will get the job done. The fence and the table are both stepped to allow clearance when operating the drill press. The parts are roughed out on the bandsaw and then sanded to the final shape.
While I've made round insert plates and square insert plates, in the past I've always made them so that the plate was centered on the axis of the bit. That's logical, except that the problem is that the center of the plate gets chewed up quickly, and all of this material out here is more or less wasted. And so as I replace plates, I have to do it more often, and I'm not getting full use out of the material. Why it took me 30 years to figure this out, I have no idea. But in this case, we've shifted the location of the plate forward of the drill press axis by an inch. So now as the bit comes down, it's not hitting the plate in the center, and I can rotate the plate as it gets chewed up and get more use out of it before I have to throw it away and create another one. And so we're going to incorporate this into the drill press build as well. It's a simple addition, but it's really logical if you think about it, and I have no idea why it took me so long to figure this out.
The opening for the throat plate can be made in a couple of different ways. It features a 3.5-inch opening with a 1/2 by 1/2 rabbet all the way around. One method is to make the 3.5-inch through hole using a circle cutter. This is best done by cutting halfway through from one side, then finishing from the other side using the pilot hole to guide the cutter. A rabbeting bit is then used to cut the step that'll accept the throat plate. The step needs to be slightly deeper than the 1/2-inch plywood that the throat plate will be made from. Another method is to use a router with a trammel. The CRB7 from Empower Tools allows for accurately setting the 4-inch cut first, then resetting to 3.5 inches to cut the through hole. The base of the drill press table can now be completed by drilling the mounting holes for the vertical face. These consist of 1/2-inch counterbores drilled a 1/2 inch deep, finished with 1/4 inch through holes drilled at both locations. It seems like every drill press has a different pattern of holes and slots for securing things to the table. But here's a method that should work for most any drill press. Clamp your table in its final working position to your drill press. Then use a pencil to trace out whatever slots are in the cast iron. Holes can then be accurately drilled inside these tracings for 1/4-20 threaded inserts. Simple mounting plates can then be made that span the width of the cast iron slots. These are being made with the circle cutter, but they can also be cut square on the table saw. A set of 1/4-20 knobs is used to firmly clamp the table to the drill press.
Clamping the fence to the table is one of the first changes I made to what I've built in the past. Typically, I would have a track here, either a T-slot or a piece of T-track or something like that for the fence. The problem is that those tracks always got filled with the debris from the bit, and moving the fence became something of a fight every time I wanted to do it. So we're going to use Microjig's dovetail clamps in a dovetail groove plowed across the bottom of the fence. The table overhangs the cast iron table that came with the drill press, allowing me, just like a router fence can be done, to clamp on the outside and put the fence anywhere I want. I can just loosen the two clamps, adjust the fence accordingly, tighten the clamps back up, and the fence is simply not going to move after that. It's an easier way to work, and the drill dust, the chips, none of that gets in the way of doing this.
The fence can now be assembled from the parts that were prepared previously. The base gets glued and clamped to the back of the face, and triangular braces glued across the joint to keep the fence square.
Now, maybe my favorite feature on this table is the ability to drill tall parts on the end without rotating the cast iron table of the drill press. The problem is that the cast iron table that comes with most drill presses does not have accurate and positive stops at the horizontal and vertical positions. So in order to drill tall pieces, the cast iron table has to be rotated, then manually set to be parallel with the bit before the drilling can happen. And then when you're done, it has to be reset to the horizontal, and again, very carefully positioned so that it's perpendicular to the bit. There are no positive stops like you might have on a miter gauge. And so that process is laborious, and if it's not done right, your drilling isn't accurate. Now here what we've done is we've put a vertical face on the back of the table. That way, we don't have to loosen the setting on our cast iron table at all. All we need to do is loosen the collar on the post of the drill press, rotate the entire system until the bit is over our part, and go ahead and drill.
There are two sizes of vertical faces because there's two different sizes of drill press. Both include a pair of horizontal dovetail slots to allow for clamping the parts to the vertical face. And both feature a dovetail groove on top for mounting to the table. But you'll also notice two different styles of mounting bracket. The wood bracket can be solid or glued up, and one corner gets substantially beveled. And dovetail slots are milled down the centers of the two square faces. The vertical face needs a pair of counterbore holes to connect to the wooden block using Microjig's dovetail nuts. The wooden block slides over these nuts, which are then secured in place. The vertical face assembly connects to the back of the drill press table using the holes bored there previously and another pair of dovetail nuts. The block provides a surprisingly rigid mount for the vertical face. For most of us, plywood is a little bit easier to come across for attaching the vertical face to the table. At first, the plywood bracket was simply pocket screwed to the back of the vertical face, but it just wasn't stiff enough to support the parts properly during drilling. This issue was easily solved with a pair of ribs glued across the back of the vertical face. The vertical face assembly with the plywood bracket attaches in the same manner using the same dovetail hardware. Whichever bracket you use, the vertical face needs to be squared to the table. A pair of pilot holes can be drilled and countersunk into either the plywood or the solid wood block, and then screws fastened in these holes. These screws will act as the adjusters, and can be turned in or out until the vertical face is square with the drill press table top. Take the time to get this right, or the vertical face will be of little use. The final step in building the table is to make and set an insert throat plate, and it should be cut from a good quality piece of 1/2-inch plywood. It can be made using a circle cutter in the same manner as the mounting washers were done earlier. A finger notch cut into the outside edge makes it much easier to remove or turn the insert as needed. And Forstner bits are excellent for drilling partial holes like this. Now, if you have one, a CNC machine is ideal for making insert plates like this. It can cut the parts quickly and highly accurately, and details like the finger hold are easy to include. And best of all, anytime a new insert is needed, it's just a matter of calling up the program. I have the files on hand to be able to instantly make an insert plate for my bandsaw, table saw, and now drill press. The rabbet for the insert plate was cut to a 1/2 inch deep to ensure that any 1/2 inch plywood insert could be adjusted up to make it flush. 3 pilot holes with countersinks are drilled around the perimeter of the insert, so that number 6 screws can be adjusted to level the plate with the top of the table.
There are any number of ways to use a drill press table. Some obvious, some not. The first method is to simply locate the piece under the bit, hold it in place with your hand, and make the drill. With this table, we can also use the dovetail clamps from Microjig to hold the part in place while we do the drilling. This is especially useful when drilling metal parts, because sometimes as the bit exits the back of the metal, it wants to grab and spin the part, which can be dangerous. This prevents that. For drilling multiple holes along the same line, the fence can be brought into place adjusted to the right position relative to the bit, in this case the line that's drawn on here, and quickly locked into place. This allows us to drill holes along a given line without changing the fence position. And all the holes will be in the same relative line. The only adjustment here is side to side. Bringing in a stop block, which uses the dovetail hardware along the groove in the fence, we can set to drill the same position in a number of pieces. And all the holes will be in exactly the same spot relative to the corner. And for pieces that require very accurate drilling, we can use the stop block to set the position and hold the piece vertical, add a clamp in the same groove, and be able to have complete control over the stock we're drilling. And the combination of a good quality bit, like this fish wave cutter, and turning the insert plate to give me a clean back allows me to drill holes through parts with virtually no tear out on either side. Having a removable insert plate also allows me to take it out, so when I'm using a drum sander or other piece that has a boss at the bottom that would keep it off the level of the table, it can be brought down into place and used for sanding without having to build something to hold the piece up above.
To use the vertical face for drilling into the end of tall parts, first the fence is removed. Then the lock on the column clamp is loosened, and the table rotated around the column until the bit is above the vertical face. The part is carefully positioned under the drill bit and clamped to the vertical face, ensuring that it's perpendicular to the table. The part can be drilled as needed, and the very careful setup of the cast iron drill press table is not disturbed. The dovetail grooves in the table simplify the process of making shop-built jigs and fixtures for specialty drilling. Using the match-fit hardware, clamps, or a combination of the two allows setup of pretty much any drilling operation.
If you're a regular viewer of our show, you may have noticed that the drill press table wasn't supposed to be the next episode. In fact, it wasn't in our program at all. This folding deck chair was supposed to be the next project, and it is coming up next. But in starting to build this project, I realized that there's a lot of precision drilling that needs to take place so that everything can fold appropriately. So it occurred to me that building a good quality drill press table will not only help people follow along with the chair build, but it's something that everybody needs in their shop anyways. So it was a good addition to this season. Stick around for the next part of the show, which will be our chair build, and we're going to start it with a visit to a very interesting lumber yard to figure out what's the best material to build the chair out of. So join us for the next episode of Woodcademy TV. Woodcademy is made possible with the generous support of our sponsors. Please take a minute and let them know how much you appreciate it.